Or what else warms vapors? High expansion foam to some extent. If I put 3-4 feet of high expansion foam on top of the pit, the vapors have got to come through it to escape. What are they when they pop out the top of the high expansion foam? Considerably warmer than they were when they were first created. High expansion foam will warm vapors, cause that downwind plume to diminish. Will it necessarily stop the vapor production? No, but it warms them. Water patterns will warm them. Again, easier said than done. The wind's got to cooperate. The pattern's got to be, the capability to put the water out there has to be there. And there's another thing about that. If you're using water to warm vapors, you got to make darn sure that it doesn't what? You got to whether you're using water for vapor control or using water to protect exposures from the heat of a pool fire, you got to make darn sure you know where that runoff is going, or you'll find your day go south really fast. So what I talked to them about is vapor control techniques: spill confinement, the confinement issue, high expansion foam, and the water curtains. The confinement we've already talked about. This is a wonderful thing if you can make it happen. It's pretty much a design issue built into the facility, not always. The high expansion foam, again, the high expansion is not going to stop the vapor production. It's going to warm the vapors. This is high-X on about 8 inches of LNG in a 4-foot deep pit. A little piece of video here, if I can get this to work. And there we go. The initial discharge of high expansion foam in a 65 square meter pit, 2 generators. As these things wind up, there are ways to stop this on a fixed system design, but this isn't a fixed system design. Before those turbines wind up, what's your foam solution going to be? Before those fans too wet, you're going to get some vapor production. Now you can design that out of a fixed system if you do it carefully. There's the spill with the high-X on it. The vapors are still there. You can't see them. They're warm coming out the top. Now just to prove that to the students, oh computer, what I normally do is once we've applied foam to a non-burning pool like that, and you can still see some of the vapors coming out of it, wisp here and there. They'll find kind of path of least resistance. And what they'll do, once they find that path of least resistance, they'll continue to come out that little channel they form. The foam will start to freeze, and you'll get these little frozen foam tubes all the way to the top. And as the foam starts to drain out and drop out, the tube will still remain there, kind of like little crawdad holes or whatever. Invented little volcanoes. It's frozen. It'll stay there. So it's kind of amazing. Even when you burn it and put it out, you've had pretty good heat above the foam, the darn ice tubes will still be there. That's the kind of testament to the insulation capability of that foam blanket. What I'll do, though, is just to prove the fact that the guy said, hey, the vapor stopped. No, they didn't. Bob, show it to him. Bob will take that torch or flare or whatever he's got in his hand, and he will simply just wave the magic wand over the foam blanket, just to bring home the fact to these firefighters that no, those vapors are still there. They're just not condensing moisture, they're not visible, and they're going vertical. And once we start that fire above that foam blanket, what's it going to do to the foam? So what do you need to do? They tell them this is a constant operation. You're going to be topping off for the duration of the burn. The water curtains, these are wonderful things also. I'm a very big proponent of, I guess, fixed systems in facilities because honestly, if you're going to lay high expansion foam or you're going to put the water curtain up to deal with a vapor cloud and do it in a timely manner, it's almost got to be a fixed system. The time it takes to deploy the water curtains, to get people on scene and deploy portable foam generating equipment, your emergency probably would be over if it's a moderate spill by the time they got anything in place. We used to have to drag these water curtains around as 3-inch supply hose, and invariably, as soon as we'd set them up downwind for the demo, what would happen? Wind would shift. So you'd drag all this floated 3-inch over here and set it up, and as soon as we set it up, get the demo going, the wind would shift. And it's a nightmare. So I found somebody with some pocketbooks. I said, please, do me a favor. And I have a 360-degree fire main around my pits now with 28 water curtain devices. I don't have to drag that hose anymore. So no matter what my wind direction, I just kick on the appropriate devices. But they will do a darn pretty good job of not stopping the vapors, but warming the vapors. And maybe this is a little piece of video will demonstrate that. And again, this is done before I had the 360-degree coverage. Come on, there we go. This guy here, one of my instructors, could put a little water in the pit and make some vapors. There's my water curtain. I've strategically set them up downwind. I had 3 of them. The vapors are going through the water curtain. It's not a barrier. They're going to pass on through. The thing is, they're going to be substantially warmer when they come out the other side. And that's the whole goal of it. And if you go downwind of that, if you want to stand in the water mist, go downwind of that curtain, you take a portable gas detector, you're going to get 4%, 5%, whatever you may get as the gas comes through that curtain. But it's warmer, it's buoyant, and it's going to dissipate. You're also getting some mixing action. You're getting some air circulation around that water curtain, so you're increasing the mixing as it goes on. And what's my wind done? Shifted. So I guess there's no magic. Maybe no magic one solution for any given problem. The pool fires, very quickly here. I think same thing you're saying. I'll talk about steady state burn rate. In other words, a pool fire where I'm not increasing vaporization from some outside source. I'm not pouring water in the pit. And typically the literature's, what I see observing 20 years worth of pool fires in the literature coincide 2 to 3 times the diameter of the pit is about what my flame height will be on a steady state burn rate. I'm not agitating the fire. Again, we've talked about the heat output and so forth. Most of my first responders in my classes, the students will say, if I park them next to a 100 square foot pool of gasoline burning and I go park them next to a 100 square foot pool of LNG, most of them are going to say the LNG pool fire is noticeably warmer. And it's for this simple reason: I'm burning it off 3 to 4 times faster, depending on whose literature you read, than I'm burning a similar size or a gasoline pool fire. Obviously, he said the gasoline's got a higher BTU content, energy content, but I'm burnt.
The BTU content is the same by mass, by volume.
By volume.
By volume, it's double.
It's double. The LNG is burning 3 to 4 times faster. So I'm just putting it out fast. I'm putting out heat faster. And most firefighters say it's definitely a warmer fire. What are their options for that pool fire if they decide to? One option would be to put it out. Now, if they're going to put out a pool fire on the facility, what are they going to put it out with?
Please, not
Did somebody say dry chemical? If they're going to say, I'm going to put that fire out, I'm going to extinguish it, probably they're going to put it out with dry chemical. We'll talk a little bit about the use of dry chemical. I'm going to get on my soapbox here for a second. We're going to talk about water application and the use of high expansion foam very quickly. And this is what I tell my students, and this is over 20 years, this is my observation. Application technique when it comes to dry chemical. Application technique is everything. Okay, I honestly, 20 years I've been at that little fire school down in Texas. I've seen more dry chemical wasted and sacrificed to the great fire god than you could possibly fathom. All primarily because of poor application technique. There's only like 4 or 5 simple little rules. In fact, the old Ansel, if they put out a pamphlet, I guess they still do. In fact, they do it drawing kind of cartoon form or a drawing. It explains those 4 or 5 or half a dozen rules very concisely, very, very, very plainly. And I guess maybe this is my soapbox. I deal with a lot of industrial fire brigades, industrial training, and so forth, and it's a guy thing, I think. This is my personal reflection. We take a guy, fire brigade membership 101. First thing we teach him how to fire chemistry and how to use a portable extinguisher. And as soon as we get that done, boom, out of the way, we go on to what? Bigger and better fires. We want foam operations and pumpers and large fires and ICS incident command systems and staging areas and high flow and 10,000 GPM foam monitors and 1,000 GPM water monitors. And we kind of go through that how to use a portable extinguisher real quick. Okay, let's get that stuff out of the way. Let's get to the big boy toys. It's a guy thing, right? You go to fire chief. Everybody's standing around, something called the Terminator or the Eliminator or Top Gun. It's got 10,000 GPM flow. None of the guys are hanging around the portable extinguisher booth, right? How many of y'all teach at a fire school? Except maybe the Ansel guys. I apologize. Okay. Nobody wants to be the instructor at the portable extinguisher prop. We want to go to the 2,300 square foot hydrocarbon spill fire with the foam operations. We kind of we skim over the dry chemical application and move on. And I've watched this at the field. There's an industrial brigade. They're down on my ship because the deck's a great hydrocarbon prop. The whole deck's burning. They got an incident command system. They got a safety officer. They got the vest. They got the radios. They got a staging area. They got a pumper. They're flowing foam. They got the whole thing down. They got the communications. They got they got it all down. And on that prop, in the middle of this fire, is two little flanges blowing gasoline in a drip pan as part of the whole deck burning. It's gasoline. Are you going to put it out with water? Probably not. It's a 3-dimensional fire. Are you going to put it out with foam? Probably not. So they grab the extinguishers. Okay, there's no valve to shut. They can't shut a valve. This prop has got 2 flanges burning gasoline and a drip pan. So by Ansell's manual, probably 2 extinguishers. There's some obstruction involved. Upwind, downwind, bottom up, both sides of the valve body at the same time. Fire goes out. 2 extinguishers, 20 pounders, sodium bicarb, 40B extinguishers. Now, there's our students. They're not going to be perfect, so let's give them 4 extinguishers because they may not get it the first time, right? Fair enough? 46 extinguishers later, this prop is still burning. There's a pile of dead extinguishers over here by the ship prop, and this flange is still blowing gasoline. And they're scratching their heads. And they're screaming, we need more extinguishers, we need more extinguishers. Have you used them all? There are no more. Well, what do we do? I said, you better come up with plan B, because we're not turning it off. They had everything down, incident command, staging, command post, all the foam operations. They had forgotten how to do what? Apply dry chemical agent. 4, 5, 6, maybe half a dozen simple little rules. They violated every one of them repeatedly and learned nothing from it. In an LNG facility, you can't afford that kind of error or omission. I mean, if you're going to put a LNG fire, pool fire, whatever out in an LNG facility, what are you going to put it out with? Okay. But a higher flow rate never hurt anything. Okay, I'll talk a little bit more about this particular fire here. There's a guy with a 20-pound sodium bicarb 40B. This is a pretty impressive fire. It's the same 10 by 10 pit. I'm going to talk about why that fire looks so impressive. He doesn't put it out. But there's nothing like higher flow rates. And I love, I mean, you know, in an LNG facility, you know, you have to have the portables. I would really like to see, if I'm looking around, like something like a 350 wheeled unit strategically placed, you can knock some fire down with a nice 350 or on up or a hose reel system. You can really knock some fire down if the application technique is correct. Even if you take a 2,000, 3,000 pound skid unit, and this guy's having a blast with the turret, the whole 65 square meter LNG pit's on fire, the next pit's on fire. He's knocking some fire down. He's loving it. But even if the flow rate's this high, the application technique still has to be correct. You can fail to put a fire out because you violated the rules even with that much flow rate, and I've seen that done. I'll get off my soapbox. We talked about the water thing here and the being very conscious of where any water is going in relation to that LNG pit. Now we're purposely doing this. Occasionally I'll have a student, a first responder, firefighter, a guy from San Diego, LA, hey, I can put that fire out with a water hose. I think I can do it. We let them try. And never say never. I've seen it put out maybe 2 times in 20 years. It's like blowing a candle out. They simply push the flames away from the pit, keep them out far enough. They're lucky. Normally they're not going to get it. All I'm going to do is accelerate combustion or vaporization and increase the size of the fire 2 to 3-fold. And then the students get really, really hot. Now we talked about, you know, heat levels so far away from the pit. If your operation in proximity to that darn LNG pool fire in normal bunker gear, it will protect you up to its design limits. There's a point where the heat is simply going to start coming through. They need to realize that. Firefighters kind of hate to give up. You know, they hate to admit defeat, and they'll hang in there a long time. They need to understand that that gear is only going to protect them up to a point with that kind of heat load. The water sources, it's not just the firefighting water, it's not just the cooling water. You really got to watch any other. And if you've got, this case, this is up in the Grand Canyon. If you've got facilities up in the cold, frigid north, you got snow on the ground. If your berm's full of snow the day that LNG flows in that containment pit and lights off, take pictures, because it's going to look spectacular. This happened to us up there. We were supposed to go to the Grand Canyon in June and do a class up there for a fueling station, kind of we were the training component of a LNG, CNG fuel station installation. And I said, oh yeah, I've never been up there. So June turned to July to August to September. December 13th, we're up there. Now that's a great time to be there if you don't want crowds, because there are no crowds in the Grand Canyon on December 13th. But there were 6 inches or so of snow on the ground, and they so graciously dug the pit for us, 10 by 10 pit, in a laydown yard with all the gravel and cinder, whatever they put on the roads, these utility yard. It's this gravel and dirt pile or gravel piles. And the first day 1 in the morning, there was 6 inches of snow everywhere. This is day 2. We lit that pit off, and it would look pretty good. As soon as we lit that pit off, what the snow started doing. And unfortunately, most of the grade went right to where they dug the pit. At that point, it's like, I can't control it. and that runoff continued for the most part of the first day. Now, most of the snow at this point is already melted. In this case, we're adding water to the equation through a fire hose. There's another one of my silly persons. That's not Bad Bob. That's somebody else standing down there waiting on it with a torch in his hand. But rainwater, snow, your water sources that are going to cause your day to go south may not just be out of the fire hoses that you're using in that particular incident. Nice lazy burn back. At this point, I think we're going to let it burn back to a pool fire. He'll stop putting the water into it. Once he stops putting the water into it, watch the flame height. It moderates on down to a steady state burn rate, that 2 to 3 times the diameter of the pit, 10-foot pit. As soon as you start putting the water back on it, nice and gentle, aggressively, however you want to do it, flame height increases, BTU output increases, and it just becomes a nastier problem. Now, if you wanted to make the LNG go away faster, that's one way to do it, but you have to be able to live with the heat load. I think at some point here, my coworker is going to come back by and take the hose from me and show me how to really do it. But watch him. I talked about the PPE issue. He's going to show up here on the camera here shortly. I'm already hot.